This black surface can get hotter than the air around it, and once you understand why, you'll start noticing it everywhere. And no, it's not producing heat. It's just sitting there, under sunlight. I tested this with two surfaces, same material, same size, same position in the sun. One was white, the other was completely black. After a few minutes, the difference wasn't small. The white surface stayed warm. But the black one? It got hot enough that you wouldn't want to touch it for long. So what's actually happening here? Because it feels like the black surface is generating heat, but it isn't. Sunlight carries energy. When that energy hits a surface, three things can happen. It can reflect, it can pass through, or it can be absorbed. And only one of those creates heat. Absorption. White surfaces reflect most of that energy. That's why they stay cooler. Black surfaces do the opposite. They absorb most of it. So instead of bouncing energy away, they keep it, and that energy builds up as heat. But here's the problem with that explanation. If it was only about color, then every black object would heat up the same way. And that's not what happens. Some black surfaces get extremely hot, others don't, which means color is only part of the story. And once you see what the other part is, this stops being obvious and starts being predictable. So if color isn't the full answer, what actually decides how hot a surface gets? It comes down to one thing: how that surface handles energy after it absorbs it. Because every surface is doing two things at the same time: taking energy in and letting energy out. The temperature you see is just the balance between those two. If it absorbs more than it loses, it heats up. If it loses heat just as fast, it stays stable. Now here's where things split. Some black surfaces absorb heat but release it quickly. Others absorb it and hold on to it longer. That difference is what creates the extreme temperatures. Think about a black painted wall. It gets warm. Now think about a black metal plate in direct sunlight. That gets hot. Same color, different result. Because metal stores and transfers heat differently. But there's another layer most people miss: surface texture. A smooth surface reflects a small amount of light, even if it looks black. But a rough, matte surface, it traps light. Light hits it, bounces between tiny angles, and instead of escaping, it gets absorbed. So now the surface isn't just absorbing once, it's absorbing multiple times, and that increases the total energy it keeps. Here's the weird part: sometimes a black surface in sunlight can feel hotter than something actually producing heat nearby. Not because it has more energy, but because of how that energy is stored and delivered. Now combine everything so far: more absorption, better heat retention, less reflection. That's what pushes temperature higher. But even after all this, there's still something that doesn't fully make sense, because none of this explains why it feels so intense when you touch it. And that's where most people get it wrong. At this point, it seems simple. The surface absorbs more energy, so it gets hotter. But that still doesn't explain one thing. Why does it feel so much hotter than the air around it? Because what you feel is not temperature alone. It's how fast heat moves into your skin. And this is where everything changes. Air is a poor conductor of heat. Even when the air is warm, it transfers heat slowly. That's why you can stand in hot air and still feel okay. Now compare that to a solid surface. A solid stores energy, and when you touch it, that energy transfers instantly, fast enough to feel intense. So even if the air temperature is lower, the surface feels much hotter, not because it has more heat than everything else, but because it delivers it faster. That's the difference. Think about asphalt on a sunny day. The air might feel normal, but the ground, you can't walk on it barefoot. Same environment, different experience, because of heat transfer. And when you combine that with what we already covered, high absorption, strong heat retention, you get a surface that stores energy and releases it into your skin immediately. That's why it feels extreme. Not mysterious, just physics. But there's still one final piece, because even the hottest surface doesn't keep heating forever. At some point, it stops. And that limit is what actually controls everything. So why doesn't it keep getting hotter? Because every surface has a limit. At some point, the energy coming in matches the energy going out. That's the balance point. Once it reaches that, temperature stops rising, no matter how black the surface is, and it won't heat forever. And this is where the environment takes control. Wind, air movement, shade, all of these increase heat loss. So even a surface that heats up fast can cool down just as quickly when conditions change. That's why the same object can feel extremely hot one moment and much cooler later. Nothing changed in the material, the environment did. And that's the part most people miss. This isn't just about color, it's about how energy is absorbed, how it's held, and how it escapes. Control those three and you control the temperature. Now go back to the beginning, that black surface sitting in the sun. It wasn't hotter by accident. It wasn't creating extra heat. It was just better at keeping energy than everything around it. And once you see that, you start noticing it everywhere. Cars, roofs, roads, anything left in sunlight. Same principle, different results. It's not random, it's predictable.